Good afternoon. Welcome to Lambda to Go, AWS adds containerized functions, presented by Cognizant Softvision. Today, we're going to discuss three things. One is, what have the roadblocks been to fully utilizing AWS Lambda in enterprise applications? Two, how does container support for AWS Lambda mitigate those roadblocks? And three, what would we need to implement container support in AWS Lambda? So some of the things that have been significant roadblocks to 100% Lambda adoption or Lambda for Microsoft include things like size limitations and cold starts. That was something that Lambda had a very strong reputation for when it first started out, is that it just wasn't fast enough to fit in with the rest of the application. And container support is starting to remove some of those roadblocks in terms of size and performance, because not only has the size increased as far as capacity, but also memory limits and CPU limits have been raised. But still, Lambda is boxed in on time. So, it's important to consider the use case. Even if you can fit a large machine learning model in a Lambda now, it can't run very long. It has to be done when the curtain closes after 15 minutes. Some of the things that are needed to implement Lambda in enterprise solutions are using things that you're already using in your existing code pipelines, and along with traditional Lambda processes. So in other words, the learning curve is not too high. It's really quite good. So Lambda has been liberated from 250 megabytes of space that you had to try to figure out how to squeeze tasks into, and maybe get some help from the various layers that you could talk to. And so it's gone from 250 megabyte, and that was a hard limit on unzipped files, to 10 gigabytes, so 40 times the previous capacity to perform bigger tasks. And the question I have for you is, do you like unicorns? Because if you do, that's great. Container support in Lambda will allow you to collect a whole flock of them. You can do things like music processing. You can run programs that don't run in traditional containers that aren't supported by one of the AWS available runtimes, say Lua or C. And you can do special purpose jobs that require several gigabytes of space to complete, including machine learning. And you can also take advantage of the opportunity to apply the same governance template to the containers that you run under Lambda as you do the containers that you run elsewhere, whether that be EKS or Kubernetes solution, which is EKS. So there's more potential use cases for container support in Lambda functions. For instance, you have a lot of sidecar opportunities for existing applications. For instance, let's say you had a coupon sale that had to validate a membership tier before calculating a discount for a customer at a front-end web app. But then you could also have another sidecar running analytics, so that if something that you were promoting was turning out to be a dud and not drawing in any sales, you could quickly shift gears because Lambda is just that fast in returning results. And the things that require both speed and space to process a larger data set, perhaps you would be working on a travel application and building a trip profile for someone. And so if you think of all of the metadata that comes into a single choice between, say, 2 or 3 nice hotel rooms or vacation spots, and how they compare in terms of safety and amenities and cost, and then you want to present that to the customer in a way that's really appealing, being able to collect that data and pop it in, leave it there, and then leave and let the next request take over is really an advantage to have great size and be able to have a little bit more processing muscle. So it might be good to look at a little bit of the history of Lambda to understand how they got to this opportunity today to use containers. In the beginning, when AWS first released Lambda, they were running it on micro-sized ECS containers. And the reason that they did that is because they were getting a very good head start on having security boundaries, and particularly for multi-tenant solutions. And so the only existing infrastructure that they had that could provide the type of security that was needed for Lambda was to use these ECS containers. However, they were on the hunt and looking for something better. And there's a really good video from reInvent 2020 by Chris Munn that discusses sort of what led to these discoveries. And there are several videos like that that we will link after the presentation if you're interested more in the history of it. But they didn't want the complexity anymore of managing oodles of little EC2 instances until they stuffed and overflowed the server. So the AWS team built a new virtual machine manager, and they labeled it Firecracker, and they invited the open source community to come in and work on it together with them. And it differed from other virtual machine managers in that typically a VM is not that small, and it requires a good share of resources, and it's oblivious to its host. It has no idea where you're placing it. It just knows what it needs, right? But the micro VM model was actually host aware. And so it was able to adapt and only consume what's needed and allow the resources to be better distributed across these micro VMs. So when you think of a little tiny micro VM and all of a sudden AWS is coming along and saying, sure, give us your 10 gigabyte container, how is it going to fit on this little baby VM? So there are some strategies that have been taken, and this is part of what makes the adoption of it so mild in terms of what you have to go through and how standard to regular Lambda it is. They take your multi-layer container that you worked so hard to create that Docker file and get all those layers in, and they flatten it into a single squashed layer. And after doing that, all of the artifacts in your application are chunked out into a hash table, and they are put in a cache, and it's an availability zone level cache, and they're only retrieved if needed. So, if your application calls one method 5 times, but never looks at another one, then the pieces that were cached to make that all go together will never be called, never be used, and hence the performance is really good. So they did another thing that I thought was really fascinating. In addition to that, all of your data to and from as the Lambda is processing is encrypted. And there is a long-standing problem with encryption really fattening the amount of data that is there, because a single piece of data might be called several times and have a different encryption key every time. And so it was ending up with a lot of duplication and a lot of extra traffic. And they figured out a way to give an identifier to every little chunk that held a similar or identical data. And so now they would only have to fetch that identical data once, cache it, and they would not have to fetch it additional times, even though it was, present in the cache or is cached once. So that led to performance gains. And now we can start getting a little bit into a couple of components that help this to function. And they're called the RIC and the RE. And you may or may not ever have to be hands-on with either one of them, but they'll help you understand how this works. So the RIC is the Lambda Runtime Interface Client. And this is the interface that allows your function code to connect to the runtime API. It's how, when you're isolated inside of a container, you're still able to be a Lambda on the outside, talk, think, and look like a Lambda. So every one of these clients that are the standard AWS provided clients is open sourced. So there's always community help and growth to make sure that any issues are addressed promptly, and it's not tucked away as a product that if it breaks and fails, you wouldn't know about it. And the time when you might utilize them yourself rather than just accepting the ones that AWS works on all the time for, Node and Python and a few others, is when you're building your own image and you don't want to use the managed runtime. And we'll talk toward the end of this discussion about some of the advantages and disadvantages of that. Obviously, for some special use cases, it's going to be worth absorbing some of the performance disadvantages in order to have that flexibility. So if you do use your own runtime, one thing to note is that you won't receive automatic updates from AWS. It's your own responsibility to update it as needed. And even the ones that are updated by AWS, if you want it to take effect, you have to restart your Lambda. So the RE is the runtime interface emulator. So this is something that allows you to test your container-based functions locally. It just gives you a pretend Lambda interface around you so that you can see whether or not your function will work correctly with the Lambda interface before you start to upload it to the cloud. And it saves time with troubleshooting, especially if you are 100% in the development space all the time, the dev side of DevOps. So what's the difference in container support to the pipeline that happens from development all the way over? So one of the things that is very much the same is that you are using your code and a runtime. But what happens when you are using a containerized Lambda is that you have to add the runtime to your Docker file. And Docker file or any OCI compliant container works for containerized Lambda. And so you provide a layer in your configuration just as you once would have provided it in the Lambda itself, saying runtime equals XYZ. Well, in this case, you're going to make sure that the runtime layer is the basis of your container. And so there are many advantages towards using these runtimes because AWS is customizing in order to make what they provide you match their environment very well. And so once you've done that, you're going to go to the build or package step. And again, the differences between this are light. You're going to package your code in a zip file, and you'll be stuck with that, small 250 megabyte limit. Or you can use a container and you've gone all the way to 10 gigabytes. And of course, the runtime does take up some of that. But in some of the exercises that I was doing in preparation for this presentation, if you've worked in Linux, you know that nothing is really takes up a lot of space. And so you could actually put a whole bunch of tools together to do a certain specific job and still not come anywhere close to a 10 gigabyte container. 10 gigabyte containers make people cringe, right? One of the reasons that people choose, say, Alpine as a distribution is to try to make their containers small and fast. And we'll talk a little bit more about what AWS has done in that corner. So then the next thing is just to create your function, and you would create custom layers. But if you're creating a function for a container, you're going to have to find a different way to put those layers in. Either they're going to have to be in a different container and you're going to have to be able to communicate with that container, or maybe they will work built into the existing container in the Docker file. It really just depends upon what it is and how you need to access it. And then in both cases, you'll just invoke your function. Now, if you're working with the RE, then by invoking your function, really, you're just doing the same thing you would do with Docker when you would say, run your container and then test it locally. And that is exactly the same concept, except for that there are some AWS constructs added around that. So we're going to look at a few short snippets of this in between discussion, just so that you can see what it looks like. And we will start by talking about the serverless application model, SAM, which extends CloudFormation and now supports containerized Lambda deployment. So I just listed a few of the functions of SAM. Actually, there's about 10 or 11. And it is an extension of CloudFormation. So if you think of CloudFormation as really extensive, actually, I think that as the move towards serverless becomes more broad, then this will probably grow up and just join as a main component, or maybe it'll go the other way. But SAM init is a command that will allow you to automatically create, just like you would, create a React app or an Angular app just by spinning it up. And it's the same way with SAM init, except for it adds a few things for you. It adds the YAML template that you'll need, or the JSON template. You can use either. And it adds the template that you'll need in order to deploy. And it's basically a CloudFormation deployment, but there's a few SAM-specific commands. SAM build is essentially a Docker build, and Docker works fine in its place. So the container will be recognized as present by the build process, whether you've built it with Docker or with SAM, because SAM is just a convenient construct. And we'll talk a little bit more about why AWS is building all of its own duplicate tools for these things that you can already do with another tool. So one of the things you have to be aware of is that when you do a SAM build, you don't want to have in your template file an AWS repository name before your tag, or the deploy process won't find your image locally. And then there's validate. So you've been working on this template for a while, and you've got 20 things in it that you want it to spin up for you. And validate will go through and just basically look at the structure of the template in terms of YAML and in terms of some rules specific to SAM and serverless. However, you still have all of CloudFormation on the back end. And so therefore, having a good knowledge of CloudFormation or other templating engines that use YAML before you get to this direction is probably a good thing, because SAM is small and CloudFormation is very, very large. And so you're just learning basically one detail area of a large product, and you will have to learn some of the principles behind it, or the CloudFormation errors will sink your ship. So SAM deploy then automatically deploys your template. If you add the guided switch to it, you can have a list of parameters in your template, and then it will present something in the UI saying, just like a PowerShell menu would do, where you can then elect to select which one you want to do. And it has some typical questions that it will ask, like, do you want to put a temporary registry up for your container, or do you want to use a specific one? Those sorts of things. So very helpful. So it looks like there's an extra slide in here. No? Back. There we go. Okay. So this is just a quick 30 seconds to show you what SAM init does. It offers you a choice of whether you want to use a custom template of your own or one of the AWS quick starts. And then you could do either type of Lambda, because it asks you if you want a zip or an image. And then it gives you all of their base runtimes to choose from, which is very convenient. And so then as soon as you do this, and it will clone from GitHub the application type that you've chosen. And later we'll be able to see a little bit of a directory structure of what it does. It's very, very simple, nothing too detailed. It just puts the Docker file and the template in the root directory, and then it puts the app in a subdirectory. There you go. So another interesting thing that I discovered in working through this is that it really took more than one CLI to deploy a containerized Lambda. Now, that could just be me. But first of all, the AWS CLI is really foundational. It's the one you need to start with because you set your credentials and configuration, and all of the rest of those honor these. As part of your identity, you have a user secret and a user key, and those are what you will have in your credentials. And then your configuration will usually include the region that you work with. And then you don't have to double off to these other tool sets. And you have all of the typical AWS CLI tools to kind of check your work and see how you're doing. Now, SAM is, as we mentioned, an extension of CloudFormation. And I view it as still in a growth phase. It's not fully baked, but it's getting lots of support and lots of rah-rah from the people who are helping to develop it. But it does still need some help in terms of development. And it's just very simple. But sometimes if it doesn't work, there is always more than one way to perform a task. So as people who are working in other templating engines are very well aware. So the ECR CLI is for the enterprise container registry. They weren't going to be beat by the Docker CLI. They were going to have their own. And it does what Docker alone cannot. And the reason why it's very valuable is because if you think about it, as you're sitting there at the terminal, you already have a cached set of credentials for Docker. And so if you want to tell it to go to ECR and get a container and do something with it or push to ECR, then you have to take extra steps, which, Amazon does facilitate taking those steps. And we'll look at that in a minute. But it is really much simpler because the constructs are all based on Docker, and you'll feel like you're using Docker Hub when you're using ECR. And so it's just very easy to use very similar commands with ECR and be able to push and pull to your heart's content. So, yeah. And actually, AWS is kind of, you need to be familiar with the tools that are on their stack. They've kind of borrowed a card from Microsoft, where Microsoft made everything in their suite work together. And so that could be viewed as monopolizing, but it's also really beneficial for workflow. So here's a quick clip of a couple commands that will come in really useful. And this first one is just to allow you to do exactly that, authenticate to a region to push and pull while you're there in the CLI. And you'll still have to take some extra steps with Docker. But with whatever privileges you have in your context, you'll be able to do all of those activities on ECR for 12 hours with that simple command. It doesn't require you to re-enter any of your cached credentials. It just gets them and gets you another token that is useful for that platform. So SAM is your Sherpa, but you could still get lost. So serverless places constraints on your design. And the thing is that, both sides of the fence are being worked by this tool that's an intermediary. And so you may construct everything very carefully according to, your business use case and what your application has to do, and then find that SAM won't deploy it exactly as you had constructed it because it follows very strictly the paradigms that AWS has set in place. And again, that's where that CloudFormation background will come in really handy. So when automation fails, it doesn't usually self-heal. It's usually the engineer who has to go and figure out why it failed, read the logs, set it to verbose, and then come back and fix it. And of course, error messages are usually written by people who are sleepy and have a lot of work to do, right? So for instance, I discovered that tip about the repo name not being one that's on your ECR simply by it telling me the tag was bad. Well, what's bad? So those are the areas you have to dig in and find out what the deal is. But if you repeat this cycle often enough of design, deploy, and automate, it is going to become automatic. And then comes the time for governing the automation. So you need to emphasize security, make sure that you don't step out of an automated build in order to manually fix a problem and then try to step back in, because those habits can become ingrained. So the real value in the tool is to find the things that it can do well and have it do them repeatedly, and then continue to expand the space on which you apply it. And that truly is DevOps. And that makes it easy to provide the environments that the developers need in a timely way, but it also assures that they're standardized and we don't get into that classic problem of having, several different worlds that we're building software in. And then when we get to prod, it's a heart attack because whatever we were building in doesn't match what we're deploying to. So that's exactly what this is intended to prevent. And so those skills, there's a blend on that DevOps line. And when you come over from the left towards the right, from the business over to the actual implementation and deployment, it's really good to build a skill set along there, because they don't have a hard cutoff anymore. There's nobody that you're throwing code over the wall to. They really blend together. And tools like this are what make that so. So here's an example, given that, of a SAM guided deployment, just a portion of it, because they're very, very long. If you are deploying, as I was, and one of the other presenters I saw mentioned that when he was on the AWS network and it was all internal, then the deployment's very fast. So if you're using Cloud9 or something like that, you're not going to experience that so much. But if you're working remotely and you're doing it over the public internet, you may have to go have coffee while it uploads your container, because mine was only 1.25 gigabytes and it took 15 minutes for it to make it over on a fast internet connection. So when you ask SAM deploy guided, it sends you through a series of questions. Everything that you see here, the stack name is always asked, but the things like the region and so forth, and the stack and the region are two questions that always come up. But here is where you can put your own parameters in. So, maybe you want different instances of the same Lambda to have different names for their buckets or other artifacts that you put in there. You're able to do that. And so here's the point where it either chooses to use your repository if you've specified it, or it can just quickly spin up ECR repositories for you to use. And if you've already done something, it won't repeat it. It does double check what is already in the site and what is not. And an interesting thing about it is that, there we go. So if you deploy to the same space again a second time, then you will, to the stack name, if you deploy to the same stack an additional time, then you're updating what you have already deployed. So, you forgot a bucket or two, no big deal. You'll just go ahead and put that in there then. But if you start fresh, then you're starting from the very beginning. And every area that you want to run this template in, you have to have your permissions and policies set first. So for instance, the template won't even run if you don't have permissions to the ECR repository and you're trying to deploy this. So you have to go to the user or to the group of users that are going to be doing this and make sure that you attach IAM policies to help them have access to all the things they need to run your particular solution. And one of the popular constructs that AWS is starting to have is, catalogs, so that you can make a group of services available readily to a certain group of people. And that's one of the ways to streamline. And of course, you can make a template to do all that too. But it's interesting with the ECR repository and the caching tips. It asks the question, well, should you create a repository for every application? Well, these things have impacts on both performance and security. Let's say you have an application or a suite of applications that have certain shared layers that they're talking to, then it can be advantageous to make sure that they're all in the same repository. And that goes back to that SAM template question of, are you going to specify which repository they should be in? And then there's the fact of layer caching. So the reason that AWS was able to eliminate the cold start problem is simply because they've so effectively cached their images. You know, they have every little bit of them just instantly available to you through CloudFront and, you know, whichever mechanisms they're using. And so there's really no lag with those. But when you create a custom image, you're going to have to give it time to go through the caching process. And then if you make an update, it can be painful because that's the reason for trying to make sure that if you update, you pick the topmost layer and don't disturb any of the others, because if you go back and redo something in a middle layer, you're going to go through the same process that you did of, you know, a day of cold starts before it gets to really being performant. So the other thing that sometimes people ask, and I didn't put it in a slide, but is the comparison between, say, using Fargate and using containers on Lambda. And it would really depend upon your use case, because you're paying for Fargate steadily. You know, that's a resource that you want to be available all the time, but you pay for Lambda just, you know, per execution. So there might be times when you're only firing something off a few times and it would be more costly on Fargate. But there might be other things that are just utility and they have to be there and they have to be available all the time, and you can't have them, you know, coming and going. And for those, Fargate is a really good solution. So a layer edit is a destructive write. So that's why when you change the middle layer, all the subsequent layers change too. And the other last point on that is that custom distros, you know, normally working with Docker, you're like, okay, how small is that? I want to get the whole thing below, you know, 450 megabytes or whatever. And actually, it can be more costly to go outside and try to make your own compact image just because of the caching that was mentioned before. And there's a link here to some of their commentary on that. So let's pop over to IntelliJ for just a minute and look at what this looks like. So probably a lot of you have visited serverless land, and it has all kinds of Lambda templates and other templates that you can use to quickly, you know, combine following a best practice with also being able to use the tools and not having to write everything yourself. So what I have done is I took a template that someone had, and it is to go from an SQS queue, and you take a big image from one bucket, make it smaller to a thumbnail, and put it in the other bucket. So the part that was interesting so far on this was just working with the Docker file. They were using that very old tool, Image Magic, with a GM on top of it, I think it's called, which just modernizes it for Node. And so the things that have to change is that you cannot have a layer inside of here. You can't just, you know, call that from another place. You either have to install it into your container or you have to call it from another container. So, and there are some things through here that came in handy. One of them is that you can set dependencies. So you can set an order of execution. If the bucket has to be there before the queue can start, then you can create the buckets first by setting dependencies. And you can also use parameters, as was noted at the top. And so those will come out through the CLI for SAM, and then you get back outputs. And this is particularly helpful when you're testing locally, because then you will have all of the names that were assigned that went in, and they'll come back to you as something that you can then work with your local tooling. So, and there was one other thing, this function. So this function, for instance, requires both a literal label of a local value and then an attribute of that value. And so, for instance, when you're going down through your resources, this was failing at first because of the way that the input from the UI was not showing up in time for the function to receive it. So it required some changing things around to get this to build. But as you can see, they're not very hard. And a little different approach, like with Azure, I used to put all of those, build those ARM templates. I would put all of the environment switches in the same file, just do a whole nother group, and that would get kind of long. And what you can do here is you can accompany this with a JSON file. And so in here, you can just have a reference, and then you can target the place that you want to go. So the Docker file on this one, you'll notice where we're pulling from. This is one of their images. The newer one was 14. I just happened to use the same one that was in the example. And if you're working in IntelliJ and you have the Amazon extensions installed, all of these things will autocomplete, make it easy for you to do the right thing. And then you're taking the root of your application and moving that to the Lambda task root. And then you can start to customize your container. And you can easily see how my container got so big that it was 1.25 gig, because I was trying to directly install all of these things. And this particular old package has just a boatload of things it depends on. So once you're done with that, then, command is, where you're going to enter your container, just as always. And so in the template, it also recognizes the handler. Let's see, I may have it under the function but anyway, you can specify the handler either place, but remember that when you're using SAM, the template will override what's everywhere else. So. That was the last of the talking points. Does anybody have any particular questions about the process? It's crickets out there.
Oh, we have one.
Okay.
It says, if you have a Lambda that is too big, is there any way to view it in AWS?
Too big to put in the 250 megabyte limit? If you wanted more space for a small one, you would just have to take that same code and have it run in your container. And then the Lambda service would call it as a Lambda function. And that you would get a lot more space by using a container. So, and that is one thing that I can show again, as I was going through this IntelliJ, is that when you come down to the function, you need to select a package type, which is image. So if it were not image, it would be zip, just as we saw in the little CLI that spun up a sample application for us. So when you choose image, the things that you have to remember when it comes to layers and so forth, the reason that you can no longer tuck a layer in here is because when you're in a container you're in an isolated environment and everything, all the processing happens within there. You're not outside directly able to access those AWS services. And instead, you access them all through the runtime interface. So there's a capacity for having larger items, but you'll also have to do some planning as to how to make your Lambda function do all the things you want it to do.
He responded, he said, that makes sense. I have been trying to use some tutorials for integrating Amazon Connect with Salesforce Lambda and wasn't able to see the functions.
You weren't able to see the functions in the CLI, or that you do bring to mind another thought, which is not so much about how to view your functions. And some of that might have to do with access if you couldn't see something and, or being on the right console and in the right region. Sometimes that's confusing because if you've deployed something somewhere and you look at the wrong region, you might not find it. But also CloudWatch has extra tools, or CloudFormation has extra tools that you can use to list. For instance, you can list all of the sets that you have created, all of the deployment sets, and then you can choose to delete them. You can use SAM to delete them, but you can use CloudFormation to find them and list them and see their status. And if one has failed, it will say, that it's in a rollback state and it'll have to be deleted. And actually, they're working on a new command that helps to get rid of those that have rolled back, because unlike the ones that you do, they have to be manually deleted, all the assets that you deploy. So that's what I mean by they're still working on the maturity of the SAM tool to get it to do everything that it should do. But considering the fact that you're working in a distributed computing landscape that is absolutely massive, like you're one little dot in the middle of the Sahara Desert, then it's really marvelous that it is able to track those assets for you and actually kind of solve the problem that you're mentioning, that, it's hard to track where things went in that vast landscape. Well, now you have basically an accounting record of where everything is based on your scripts.
Perfect. Thank you, Ramona. We don't have any more questions.
Okay. Thanks, Rosina.